Hi, my name is Professor Bill Mitsch. I'm excited to show you our wetland culture project that will potentially solve the phosphorus pollution problems in Ohio, Florida, and elsewhere. More than 750 aquatic ecosystems worldwide currently suffer from large-scale impairment due to urban and agricultural inflows that cause water quality degradation. In Florida, we have seen major changes in biodiversity in the fringes of the Florida Everglades because excess phosphorus has shifted existing sawgrass plant communities to invasive cattails. In addition, because the Everglades are now being insulated from excessive runoff from Lake Okeechobee to the north, we have had several episodes recently of polluted discharges being diverted from the lake to the Atlantic Ocean and the Gulf of Mexico estuaries.
I'm Captain Mike Connor, charter guide in Martin County, Florida. I've been here nearly 20 years. I've seen a lot of events like this. You're looking at 4.7 billion gallons of nutrient-laden polluted water coming from Lake Okeechobee and other ag lands west of our county and north of the lake.
Then 6 months later, in 2016, harmful algal blooms occurred when temperatures increased, leading Florida Governor Scott to declare a state of emergency over guacamole-thick algae in these rivers and coastal areas. In Ohio and the Midwest, excessive phosphorus has caused harmful algal blooms in one of the Laurentian Great Lakes, Lake Erie, threatening an $11 billion tourist industry, and in 2014, shutting down the water supply for the city of Toledo. We believe these problems can be solved by ecological engineering, which is defined by us in the 1990s as the design of sustainable ecosystems that integrate human society for its natural environment for the benefit of both. The field is now accepted by many universities and the National Science Foundation and includes approaches such as wetland treatment systems that have been tested thoroughly over the past 40 years. But our approach involves wetlands with a twist. We call our overall approach wetland culture, a combination of wetlands and agriculture, horticulture. The three models that will be used include: 1, replicated wetland mesocosm models in distinct regions and climates with significant nutrient pollution. Number 2, a mathematical simulation model of wetland agriculture systems that can be applied to different landscapes and climates. And number 3, a landscape business and feasibility model that investigates the economics, operating model, and social feasibility of taking our wetland culture approach to full scale. With a recycling mechanism that will return those nutrients directly to agricultural production, there is also reducing the requirement for additional fertilization for agricultural production. Thus, the concept of wetland culture will contribute to breaking the vicious cycle of nutrient runoff and cascading harmful effects to downstream environments while providing a more sustainable agricultural landscape. Our team of 11 scientists, engineers, and business model specialists from 6 universities and 1 consulting company are committed to a decadal scale investigation of the wetland culture approach, as there are many design and social questions that will be needed to be answered at mesocosm, mathematical, and business scales, but also at larger pilot and full-scale experiments. Our proposed research described in our Barley Prize proposal of integrating wetland nutrient removal with recycling of these nutrients to agriculture is urgently needed to provide a middle ground that allows for ecosystem services of wetlands to be utilized in conjunction with a more sustainable agriculture. Thank you for considering our proposal for solving this important environmental problem. We look forward to your review of our Barley Prize application.